Hi everyone, we're continuing on with using elimination, or what the textbook calls addition, to solve systems of linear equations. Okay, so let's look at our first step. Our first step is to pick a variable, either x or y, to be eliminated. And remember, we're looking for variables that have the same numerical value but opposite signs for their coefficients. So let's look at our coefficients. So we have a positive 3x and a positive 2x. Unfortunately, right now, neither 3 nor 2 have opposite signs or the same value. So again, if I were to just try, without doing any modification, to add these two equations together, you can see here that nothing is canceling out, nothing is getting eliminated, which is the whole point of the elimination method. Okay, same thing over here. If I look at 6y and 9y, they have the same sign, whereas we want opposite signs, and clearly 6 and 9 are not the same value number. Okay, so this is probably more challenging than the last video I posted, because there are no numbers that I could multiply just one equation by in order to get my coefficients to be the same value and opposite sign. So there's a few ways I can do this. One way, possibly the most obvious way, is if I multiply the first equation by -2, and I multiply the second equation by 3, right? The reason I chose those numbers is because 3 times -2 is going to give me -6x, and 2 times 3 is going to give me positive 6x, which achieves my goal. My goal is to have coefficients that have the same numerical value and opposite signs. Now, as you hopefully recall, I can't just modify one term in an equation. If I'm going to use multiplication, I have to distribute this -2 to every single term. So let's go ahead and do that and fill in the rest of the equations. So 6 times -2 is -12y. -9 times -2 is positive 18. Likewise, down here, we already did that guy. This is positive 27y. And, oh, gee golly, that's a big number, huh? I believe, you can check my math here, I think that's going to give you -78. Okay, so let's go ahead and see if we can add through, and let's see what happens. So this should give us 0x, which was the whole point of going through all this work. This should give us 15y, and this should give us -60. Okay, so from here, we can ignore this. It's nothing really. 0y is just 0, not even worth writing really. So then we have y equals -4. Now, I took the liberty of graphing the system of equations before I started, and I'm looking at the graph right now, and I can tell you that that is the correct answer. Okay, so we have eliminated that variable, and so we solved for, right, we eliminated x and then solved for y, so now we need to go back and find x. So if you recall, you can use either equation. My only recommendation here is that when you do that, you make sure that you use the original equation, either this guy or this guy, and not one of the modified equations. So let's see if we can squeeze that work down here. So let's say we have 3x plus 6y equals -9. Y's always get me in trouble because their tails are too long, and then they kind of bleed into the other equation. Okay, so our y is -4. So we have 3x plus 6 times -4 equals -9. We have 3x minus 24 is -9. Okay, to undo subtraction, we add 24 to both sides. We get 3x is equal to 15. We divide by 3, and we find out that x is equal to 5. So that's the other half of our solution. So together we have x equals 5, y equals -4. Now in the last video I also mentioned that you can always check your work. Okay. Again, you can check it graphically. Unfortunately, unless you own a graphing calculator, you wouldn't be able to necessarily do that on the exam unless you wanted to do it by hand, which would be quite time consuming. So in an exam setting, the fastest and easiest way to check your work is to use the other equation. So what I mean by other is we use the first equation, 3x plus 6y equals -9, to solve for x here. So now I'm going to use the second equation, which is 2x plus 9y equals -26, to verify that the solution x equals 5, y equals -4 works, not just for that equation, which we already know it does, but for this equation as well. So let's go ahead and simplify this. We have 10 minus 36 equals -26. Everything looks good to me. -26 does in fact equal -26, so we can be happy that we have solved this correctly. So the other thing I wanted to address here before I end this video, somebody might ask, what if you had decided to eliminate your y values instead of your x values? And that is totally valid. You could have multiplied, instead of eliminating your x's, let's see if I can erase this here. What we could have done instead, use a green color, to eliminate 6 and 9, we could have multiplied this guy by, I think you would have had to multiply this guy by, I want to say, either positive or -3. And then you would have had to multiply this by 2. And doing that, this would have given you a -18y. And then you would have had a positive 18y here. And therefore, you could have done the other thing. Instead of eliminating x and solving for y, you could have first eliminated y and then solved for x. Okay? So I just want you to understand, as you go through these problems, many times there's more than one correct way to proceed. I pick one way that looks fastest and easiest to me. If you pick a different way and you still get the right answer, that's totally okay. So I just wanted to let you guys know that. The way I solved it initially is not the only correct way to solve that equation.